I think Charleston is really smart. He has his mic already stuck on his face. Yeah. So good morning, Professor Soon and honorable guests. I'm really delighted to be here. I'd like to thank Professor Lewis for this very kind invitation. It's the first time I'm here in this wonderful auditorium. And I'm here to share with you some of my recent work on big data and artificial intelligence for learning and well-being. So I think when we talk about big data, many of us know it's characterized by 4 V's. Volume, but volume is not the only important characteristic. There's also velocity, the velocity in which data keeps streaming in, and variety. Data comes in many forms. It can be audio, video, clickstream, GPS, locations, etc. And also veracity. Veracity is often forgotten in big data. The volume may be big, but if the data is not fit for purpose, it may lead you to perhaps incorrect conclusions when you analyze the data. So veracity refers to the uncertainty in the data, inaccuracies in the data, and we must be very careful about that. In some of our work, we found that maybe we start out with a lot of data, but after we have cleansed the data and removed the data that we do not trust, then there's not that much data left. So fit for purpose data is very important. And most importantly, among all these V's, we need to think about value. How do we derive value from big data? So I think many of you may have seen this. This is a graphic that talks about what happens on the internet in 1 minute. And they picked 1 minute because there's just so much data. If they pick a longer time duration, the numbers will just go off the roof. So for example, those of us who like WhatsApp and WeChat, look, in 1 minute, there's like over 38 million messages and 18 million messages on WhatsApp and WeChat, respectively. And there's a lot of other interesting statistics for your digestion. Now, recently, as we have been talking about big data for a few years, we now are hearing a lot of talk about artificial intelligence. So here I present a formula, AI equals big data plus cloud computing plus machine learning. Because we have big data, we have cloud computing that can implement massive computing to analyze that data, and machine learning actually uncovers interesting patterns from the data. So AI is actually enabling a lot of new innovations. Now, what is AI? This field was actually, it actually emerged in a Dartmouth conference in 1935 by a group of pioneers, John McCarthy, Marvin Minsky, Nathan Rochester, and Claude Shannon. And from that meeting, they defined AI to be every aspect of learning or any other feature of intelligence that can be so precisely described that a machine can be made to simulate it. Now, after so many years, here is our latest characterization of AI into different branches. And you can see there's deep learning or machine learning on the top. And there is my favorite, which is speech to text and text to speech. So in fact, when I do big data analytics research, I actually cover many domains, especially on health and aging, environment, and e-learning. But my favorite has always been speech to text, text to speech, and languages. And in fact, today, I try to populate my talk with examples in this, especially because I'm here in Xi'an University, and you're a pioneer in communication, right? So speech and language is the most natural form of human communication. And I think of communication perhaps in a broader sense, not in particular to communication, education, or journalism. Maybe you can enlighten me after you hear about my work in general speech and language technologies. So I look at learning and well-being, and I'll give you a bunch of examples in each. Hopefully I have enough time to cover all these, but if not, then I'll skip some, and you can always ask me later. So on learning, I have been developing speech recognition and synthesis technologies to support language learning. This is my first example. Okay, computer-aided pronunciation training. So this is actually a very fun project because many of us are motivated to learn a language because we can make friends, we can empower ourselves, we have greater employability, and so on. And it has been estimated that there's over 2 billion English learners worldwide, and the proportion in Asia alone exceeds the number of native speakers. Now, with the new technologies, and in fact, I'm talking about speech and language technologies, which is a branch of AI, each of which takes a lot of data to train. Okay? With these new technologies, we are now able to use new learning platforms and new pedagogies to support an individualized, self-paced, private, round-the-clock language learning experience. So it's round the clock. So your teacher may get tired, but your computer-aided pronunciation training platform will never get tired. And there's new forms of visualization as well. So this problem actually brings together linguistics, speech science, engineering, and pedagogy, and of course, big data and AI. Now, when I started working on this almost 10 years ago, we actually had to collect our own data. And I focused especially on Chinese accented English, where the first language, L1, the primary language, may be Cantonese or Putonghua, and the second language is, of course, English. And so over time, we've accumulated a lot of data, and I kept analyzing the data. And so I just want to play for you, for example, this phoneme, th, right? In American English, this is what it sounds like. I might need our staff to help me play. This word?
Thick.
Okay, so this is American English for the in thick. Now, here's someone in my corpus from Heilongjiang. Okay, so this is how he pronounces the word.
Thick.
Okay, then we say, okay, let us go to his recordings and look for this word and see if he has pronounced it and how he did it.
Thick.
Okay, so there's not much of a distinction. And then we check back at American English.
Thick.
So you can see that there are certain influences, we call it language transfer effects, that move from our mother tongue into a second language that actually prevents us from discriminating between th and s, and therefore we will actually observe mispronunciations in the non-native English. Now, I'll just skip these in the interest of time. Let's think of a vowel, okay? So this is the vowel in the word caught.
Cut.
All right, now here's someone from Hong Kong.
Caught.
Okay, so we checked how he pronounced this other word.
Caught.
Which is pretty much the same. And then we checked against a native reference.
Caught.
Okay, so again, through data, we actually analyzed a lot of mispronunciation patterns. And actually, our goal is not to eradicate accent, but rather to look for areas where there may be confusion due to accented pronunciation, and we try to help correct it. In general, we feel that we're not training spies, so we do not need to eradicate accent. And in fact, accent actually it adds texture and it adds character to your speech. Now, over time, you can see it's a long and hard journey. We actually compared our approaches with other approaches, and we are now at the detection accuracy for mispronunciation detection at over 90% and diagnosis accuracy at over 84%. So these are some of our papers. I must say that mispronunciation detection is harder than speech recognition because speech recognition basically tries to recognize what you have said, but mispronunciation detection tries to analyze not only what you have said, but whether you have said it well enough. And so it is a finer-grained distinction. And furthermore, we emphasize on diagnosis so that we can help the learner more. And my students actually have started a company about 2 years ago. And if you'd like to play with it, this is on WeChat. So you search for SpeechX on WeChat, And you'll see this, okay? So this is interface where, oops, very hard to control this. Can you help me? No, not this slide. Just click the video. So this is a screenshot from WeChat, and it has phoneme practices. So it'll give you a word, sit, and then you can try.
Sit.
And it will give you a score, 5-star rating. It didn't like it so much. Okay, and then you'll try
Sit.
again. And this time, the learner got better. You can also practice sentence-wise.
He
So
goes to school on foot.
this is synthetic speech, okay?
He goes to school on foot.
And this one, the system liked it, 98.
I would like a piece of stick.
And this one is the second sentence, which the system didn't like so well, okay?
I
And
do not have the answer.
so it has lessons and exercises for you if you want to play with it. And you can also look for your own report. So like this one, the systems
Steak.
say, I don't like the way you said the word steak, and this is how you should say it. And then there's also prosody, which has to do with rhythm and the
Prosody.
stress. And this one, the learner had it wrong.
Prosody.
Okay, so the system tells the learner
Prosody.
where to place the stress. Okay, so you can play with it and just download. It's free, and you can just play with it. Now, after we've detected the errors, we needed to generate corrective feedback. So we want to pinpoint and generate feedback to help the learner. And to do that, we start with visual speech synthesis. So you can see we synthesize the animation from the frontal view and also the mid-sagittal view. And the way we do it is to look at all the articulators like the tongues and the lips, and you can see all these components. And there's a lot of data that goes into analyzing it. And we put all these together into this mid-sagittal view so that you can actually have the animation looking at all the articulators running. And we use a blending approach. And so, for example, in the vowel ow, we start with, you can see the highlight. I guess it didn't work out so well, but here it's the ah, and this is what it looks like. And then if I advance, then it will gradually round off, okay? And furthermore, we also want to exaggerate the animation. And so if you can help me play this. So this is the neutral rendition of farmer.
Farmer.
Okay, this is the exaggerated rendition of farmer.
Farmer.
Okay, and then let's say the error is in sh, the sound sh. Yeah, this is the neutral version, and this is the exaggerated version. So we actually generate this on the fly based on the mispronunciations detected from the user. And this is our labs demo, our labs prototype. We have the WeChat prototype out there, and this is our labs prototype, which we call Enunciate, the system. So this is my PhD student, and he's typing in a sentence that he wants to practice on. And you know, R is sometimes a problem.
Is rising.
And then he actually said, wait. And so the system comes back with some red text, which is the detected.
Wait.
Okay, it says U is wait,
Rate.
and the model should be rate, and this is how you should say it, and it loads the animation. So this is all on real time.
Right.
Okay, so this is how the system runs. And that's the example on language learning. My next example is on conference publication topic modeling. Now this came about a few years ago when I was technical chair of a flagship conference in my field, which is interspeech. So as technical chair, basically you have to handle the couple of thousand papers that are submitted to the conference, and then you have to put together a technical team. So these are experts. I have about 50-some people around the world in different areas. And we have to define what we call the tracks, which are the major areas, and then also the sub-tracks. So for example, one track is speech recognition, signal processing, acoustic modeling, robustness, and so on. And then the track is divided into a whole bunch of sub-tracks. So we have to define these fields and subfields, essentially. Now, my concern, because I have to oversee the whole thing, is actually I have a question in my mind back then, and I thought, even though I have the best experts that I've invited from all over the world, it could happen that the field evolves, and maybe the way we have designed the track and the subtracks may not have completely captured the latest developments in the field. So one thing I did was to use a machine learning algorithm where we feed in, the thousands of papers, and we ask the algorithm to extract the topics. So this algorithm, which is called latent Dirichlet allocation, it's able to extract the topics for you, and I then plotted the major topics in word cloud. So the font size of a keyword actually reflects the frequency of occurrence in that distribution. So from these word clouds that are extracted automatically from thousands of papers, I'm able to look at, there's like one cloud on acoustics and reverberation and the environment, another cloud on speech production mechanisms, another cloud on deep neural networks, and another cloud on pitch and prosody and so on, tone, etc. So with this, I was able to compare and contrast human-authored and AI-generated topics, which will facilitate my revision and design of the topics to characterize the conference, okay? So this is the second example, and now I'll move on to the third example. This is a conference video archive retrieval system. Now, it actually emerged from some work that I did back in 2000. I was awarded an NSF grant, and I was able to lead a team in Johns Hopkins University Center of Speech and Language Technology, and we worked there for the whole summer. And then this is my paper that came out of the talk. So I actually had a bunch of 11 team members from Johns Hopkins University, University of Maryland, Princeton, National Taiwan University, etc. And this is our paper, which actually got published in 2004, and it's about translingual speech retrieval. So it may be a bit small, but basically the idea is you have queries up top and you have documents. You have documents which are Chinese news stories on Voice of America, which is audio, and your queries are English news stories. So the idea is, what if I put in an English news story, and I want to look at how the Voice of America broadcast in Chinese will talk about this story. So this is what we call translingual speech retrieval. And what I've done is, there actually is a symposium that is organized by the Stanley Ho Medical Foundation and has been running since 2000. And since 2007, they actually record all the talks in video form. So I use the same idea to index the audio tracks with automatic speech recognition, semi-automatically, and I also use machine translation to make them all bilingual. So if the talk is in Chinese, I translate it into English. If the talk is in English, I translate it into Chinese. And then you can actually look at search the whole repository. Okay, so this is, yeah, this is an introduction.
DDDAX 係由香港中文大學何鴻燊海量數據決策分析研究中心開發，用戶可以透過桌上電腦、平板電腦或者手提電話，使用呢個檢索系統，尋找基金會自2007年到今日舉辦過嘅醫學研討會之中所收錄超過100段精彩嘅醫學視頻。系統支援喺電腦或者手機上應用。如果你選擇使用電腦瀏覽我哋嘅檢索系統，可以先進入我哋嘅網站，然後點擊研討會影片檢索系統嘅圖示，又或者直接輸入網址。如果選擇使用手機瀏覽系統，可以使用手機。
Yeah, can you skip a little bit and continue, please?
掃描我哋嘅二維碼，立即進入研討會影片檢索系統嘅主頁面。由於電腦跟手機上嘅操作冇太大嘅分別，跟住我哋會主要使用電腦作為操作平台去介紹。首先，要瀏覽歷年嘅視頻片段，
of all the talks, and if you click on each year, you'll see all the talks that year.
系統隨即會顯示
And you can click a particular year that you're interested in, and you see that year's talks.
會上發表過嘅主題。 要瀏覽個別演講嘅內容，可以直接點擊顯
So
示
you can
喺
click on a
右
talk
方
that you're
框格
interested in,
演講主題嘅連結，系統就
and
會
it goes
自行
directly to the
跳轉到
talk.
該段影
And this is
片
talk
進
by a
行
professor
播
from
放。
Oxford.
本系統
And
亦
this is
都
the
支援
video.
字幕搜尋功能。字幕搜尋功
So
能
it just
位
scrolls
於
as the
影
video
片下
plays.
方嘅位置。
And if you want to
喺
search
字
for a
幕搜
particular
尋
keyword
輸入
in the
框
audio
架
chart
裏
of
邊
this talk,
輸入
then you
要
just
搜
put
尋
in
嘅
put it into the
然後
into
點
the
擊
window,
Search
and it'll
按
tell
鈕
you all the instances of
影片
occurrence.
中曾經出現
So
過
you can
該
just sort
關
of
鍵
scroll,
字
and
嘅
if
地
you
方
see some
就會以
snippet that
同
you're
樣嘅方
interested
式
in, you just
顯
click
示
on it,
喺下
and it
方
will
嘅
play
框
10
格
seconds
之內。
before that
只要
instant
按下
of
搜
the
尋
occurrence
結
of
果
that
側面
word.
嘅時間，影片就會喺選擇位置嘅前10秒開始播放。
Okay. Now, the other thing is you can also search across all
系統收藏
symposiums.
過百場研討會嘅影片，使用者可以透過關鍵字搜索功能，喺資料庫之中搜索與關鍵字有關嘅影片。關鍵字搜索功能位於系統嘅右
So
上
to
方
search
位
the
置。
entire
喺
library,
右
you can
上
also
角
put in a
嘅搜
keyword
索
here.
欄位輸入關鍵字，搜索結果
And then
就會
immediately
喺
you can
系統
see
顯示。
all the years when there is a
包括所有
talk,
含
you know,
有
like
關鍵字嘅字
2007
幕
and so on, all the
簡
years
報
when
文
there's a
件同
talk
埋該
on
影
that
片嘅
with that
基本
keyword.
資料，點擊影片嘅主題就可以開始進行播放。你亦都可以選擇點擊字幕時間，影片會喺選擇位置嘅前10秒開始播放。
And furthermore, we also provide the slides for every talk.
一啲演
So
講會有
in a
提供
particular
簡
talk,
報下
you can
載，
actually have
使
a
用者可以
button.
透過下載功能下載簡報，喺影片播放器下
So,
點擊 download
so here you
slides
can
按
actually
鈕
download the
該
slide
影
and you
片嘅
can
簡
look
報
at the
文
slide
件
as the
就會
video
喺
goes
瀏
on.
覽器嘅
Thank you.
新分頁顯示。
Okay. So in fact, this system was just announced over the weekend at the symposium. I really like this symposium because our CUHK Faculty of Medicine actually puts in a lot of effort to pick the best speakers who are experts in the diseases at that period. And so it's a very valuable repository. And I wanted to basically put the ability to search and empower the user to just pinpoint on a particular piece of information he or she is looking for. All right, so that concludes my examples on learning, and I now will move on to well-being. When I talk about well-being, one piece of work that we've been doing is on assistive technologies, in particular augmentative and alternative communication. Now, this came about because I was actually talking to some speech therapists in the hospital authority, and they were telling me that the hospital authority actually prints this book, and you see it's called the communication book. It has on the right-hand side a bunch of menus like action, and you can see some blank squares. So if you go to a particular menu item, then you have all the categories in that menu item. And you can also personalize it by putting in pictures to add to the content. Now, the problem with this is it's aimed to serve the people who are speech impaired due to various reasons, oftentimes stroke or Parkinson's or traumatic brain injuries and so on. And they often run out because the book is very, it's laminated to protect it. It's very expensive to print, takes a long time. So then I said, well, let me help you. It's not hard for us to develop an electronic version. So that's what we did. And this is the electronic version. You can see we actually preserve some of the affordances. But the nice thing about it is that the book can speak. So the subject, who's usually speech impaired, doesn't need to point. And may we, yeah. So you can see we embed our Cantonese text-to-speech synthesis engine into it. And we also have fluid interfaces. You can resize the icons, etc. And furthermore, we give it out for free. So anyone with an iPad or iPhone can download it. And if you want to add an item to it, it's very easy. You just put in a picture, like it did, and then you put in a label, so it will just speak it by accessing the cloud where our text-to-speech engine is. And there are various customizations. You can also download let me see, download other categories other people have shared, right? So like transportation. And in fact, we
交通工具
we also collaborate with Microsoft. So we're able to now offer this
港鐵
ebook
站
in over 20 languages. Okay, so this one is the award that we got last year from Hong Kong ICT. And my second example is we actually want to personalize this AAC. Now, because I was, the idea came to my head when I saw the late Professor Stephen Hawking, and you can hear him. This is how he sounded, right? Because he was using the desktop machine. So it sounds like a machine. And I want to personalize it so it sounds more like a human. And in fact, I want to hopefully pick a voice that may match better with the face and the identity of the person. So we then started doing some research, and this is our research on voice conversion. And we actually published a paper in 2016, which got a Best Paper Award from ICME, IEEE ICME.
重新归零，然后从头开始。
Yeah, so just a moment. So let me play for you the target. So this is actually someone, maybe maybe you recognize this person. She's a movie star, and we got some of her speech from the internet. So please play the target.
重新归零，然后从头开始。
Okay, so I'm not allowed to say the name of the person in public, but I guess you can guess. So this is me. I was just saying something random. So please play the source.
Call an ambulance for medical assistance.
So this is me. And then our voice conversion system is able to convert what I said into her voice automatically.
Call an ambulance for medical assistance.
Okay, so my idea is that maybe in the future, for someone who has speech impairment, maybe I can get a bit of the vocal characteristics and personalize the speech synthesizer so that it matches better with the identity of the person. So we have other ongoing work, but I guess I don't have too much time to go into detail. Essentially, we have a paper published in Nature Partner Journal where we look at how Twitter can be best used to find a person who got lost due to dementia. So there's ways to put out Twitter messages to maximize the chances of finding the person who got lost due to dementia. And also, we have a paper in geriatrics where we gave these smart watches to over 1,000 elderly people. We look at their circadian rhythm, when they wake up in the day and when they sleep. And we find that just based on the circadian rhythm of these people, we're able to use machine learning algorithms to distinguish between healthy controls and those with early cognitive impairment and those with dementia. So finally, in conclusion, I feel that with big data and AI and for speech researchers, this is really a golden age. We have a lot of room for innovations, and we want to be able to enhance learning, health, well-being, social inclusion, and make our world a better place. Thank you very much.